Hello, everyone. Welcome to Caldwell's and Associates, the negative impact of hidden bottlenecks in manufacturing. Discrete manufacturing, most discrete manufacturing, there's bottlenecks. But what we're going to first talk about is the ideal state in a discrete manufacturing, which is one-piece flow. And in this situation, we have a push system, and that's consistent with our accounting system that says we want 100% efficiency at each one of these stations. So we have a press operation that we want to run 100% efficiency, assembly, and a pack operation. And each one of these, the reason why it's in the ideal state is because it's a balanced line, and it's 1 second to complete each one. So let's see what happens when we try to get 6 finished parts. First, we start with 1 in the press. Our clock time is 0, and we just click 1 second, and we got 1 coming out of the press, 1 going into the press, and then we click 2 seconds. We got 1 going into assembly, 1 coming out of the press, 1 going into the press. So 3, we got 1 coming out of assembly. 4, we got 1 in pack now, and 5, we got 1 coming out. Now that is our lead time, okay? So 5 seconds, we can get through this system. So let's just click through and see, at 10 seconds, we have 6 parts. So now let's look at the same system, but now we have a bottleneck. Assembly is 2 seconds. Now we're still gonna have a push system. We still want each one of these operations to operate at 100% efficiency. And we want to see how long it takes to get to 6 parts. Finished goods. So we start, and just to let you know, the bottleneck determines the rate of flow and the time, okay? So the rate of flow, it comes from the hourglass. That's where this term comes from. It determined the hour, okay? That, the sand going down, that determines the hour. So it's the same thing in bottlenecks in manufacturing. This 2 seconds is gonna determine the rate that's coming out of packing. So let's see if that's true. Again, we're gonna start with 1 in the press at 0, and we're gonna go 1 second. 1 comes out like before, 2 seconds, 1 goes in assembly, 3 seconds. We got a bottleneck started because this is 2 seconds. So let's go through it. 4 seconds, we finally got that 1 off. 5 seconds, now we got 3 behind there. And 5 seconds we got before we got it through, not this time. So that's the difference. So let's go ahead and click through and see how long it takes to get to 6. Now, what we really need is a pull system because we're building up inventory here, okay? So that's the importance of a pull system. But we got to push, and our accounting, the way we got our accounting set up is we want each one of these operations to be 100% efficient. So you keep going down. We don't have a lean accounting, so we keep going because we get 6. Now, look at that. We got 6. But look at this. This is what happens when you have a bottleneck and you're not aware of it, okay? So we got 7 parts waiting before the bottleneck. We got 6 finished. We are throughput. It takes a little longer to get to the finished goods, okay? We got 6 finished goods. It took us 16 seconds. Now let's compare it, okay? This is without a bottleneck. 1-piece flow, ideal state. This is with a bottleneck. See the difference, okay? Now, let's assume, and this is easy to see. Now let's see what happens if we didn't know that this was a bottleneck, okay? And what we did was, we didn't know this was a bottleneck because dynamic bottlenecks are hard to find. And we decided to improve this press operation. Let's see what happens. So we had a greenbelt project and somebody went down and improved the press operation. And everybody patted them on the back and said, great job. You got that from 1 second to a half a second on the press operation. Now let's see what happens. So since we got a half a second there, we're gonna have parts coming off in a half a second. So we got to change our clock from a second to a half a second. So now we're gonna go on. We're gonna start with one in the press, just like we did in other two simulations. And at a half a second, we got one coming out of the press. So that's good. Now we got one going into assembly. Now we got at 1 second. Now at half a second, we got another one coming out. And then another one coming out, another half a second. So we still got this part here because it's take 2 seconds in assembly. And another half second, we got 3 coming. So at 3 seconds, we finally got the one coming out. All right, another half a second, we got another one coming out of the press. Second, another half a second, we got another one coming out of the press. So we need that pull system. You can see it. It's even more important right now. But we got a push system, so we're pushing on through. So at 5 seconds, we got the part out in 5 seconds. So that's equal to what we had before with the one piece flow. But look what's behind our bottleneck. We got more parts. We got 5. So let's just click on through and get and see what it takes, what happens when we get to the 6 at the end, 6 finished goods. So look at that. We actually made it worse by improving the press. And this is what happens in manufacturing when you don't know where your dynamic bottlenecks are. Okay, the critical bottlenecks. All right, this is a simple illustration. You got 18 parts waiting before the bottleneck. Okay, it takes you 15 seconds to get finished good. Now let's compare. We're gonna compare the bottleneck, all right, that we had before with our improvement, which we thought was an improvement, but actually it made our operation worse. So this is what happens. If you want to learn more about, okay, dynamic bottleneck, look at this simple example, okay? This is what a dynamic bottleneck look like. Where's the bottlenecks? When you wash regular load of clothes and the dryer is the longest operation. The dryer is your bottleneck, okay? Most people, you wash clothes, you know that when you're doing a regular load, the dryer is the bottleneck. But let's say you're washing some dirty work clothes and you want to soak it in the washer. Now the washer becomes the bottleneck. Now that's a dynamic bottleneck. Okay, in this operation, your bottleneck is shifting back and forth. So if you knew this and you wanted to improve this cycle time, and you want to improve that cycle time there, then you would focus on just your bottlenecks. So dynamic bottlenecks are bottlenecks that move, and they're in manufacturing, most discrete manufacturing. And a lot of people are not aware of where they are. So when you use managing methods for dynamic bottlenecks, which we developed, it increases your throughput, capacity, and revenue. The first impact is your cash flow can be increased and your revenue without adding any cost. Just understanding where it is, you can start getting out more. So it also improves your throughput, productivity without adding costs. You can reduce your production costs too, because now when people are absent, you know where you need to man your stations by knowing where your critical bottlenecks is. Better understanding of your overall manufacturing process is key too. And then it improves your employee morale because it lets them know where they can impact their performance positively. So if you want to learn more, even more about dynamic bottlenecks and how to identify and improve them to improve your throughput, capacity, and revenue. I have a video on my website, Caldwell's Lean Six Sigma .com courses. You can go to that website, and it only costs $9.95. You get to look at the video, and you also get a PDF copy I'll send you after you sign up. So learn more so you can do more, be more productive, and hey, make more money and save more money. Have a great day. I hope you enjoyed the video.